Well, hello and welcome YouTube. Mr. Robinson back here with yet another, well, it's a video. It's a math video, and I'm going to get right into it here. I promise that I'll give you something with secant lines, tangent lines intersecting together. Now, I say secant lines in this scenario here. Technically, you can also call them chords, but, you know, it is a secant line. It's a line that goes through. The relationships and connections that we have here when they intersect within triangles and outside of triangles and all that good jazz. And I want to bring it to you right here. Maybe I'll give you a quick proof fashion to this thing right here and explain why this is what it is. What we're going to do is we're going to find some certain lengths. They just say find the variable in the length of each chord. The chords are, 3 plus 4 is this length. That's, that's DE, that's 7. And then FG is 2 plus Y, whatever Y is. And it can be a decimal, it can be a fraction. Whatever Y is right here, we can give it its length as well. But we got to find Y. So the relationship and connection here, it's a really simple one to use. The why, the how come is going to be a little different. But it's going to be this. I can set this part times this part equal to this part times this part. And then solve. I can do 2 times y equals 3 times 4. And there's the value of y. Now, how come we can do this? Let me make 2 triangles out of this really briefly for you right here. Triangle, triangle. We actually have an angle-angle relationship right here. We have these 2 vertical angles congruent here. And you can pick among the litter here. This angle G congruent to this angle E. Why are they congruent to each other? Because they are both inscribed angles of the same intercepted arc. Look at this one in green. Inscribed angle with that intercepted arc. Look at this one in purple. Inscribed angle with intercepted arc. They share the same intercepted arc, therefore they are the same angle measure. Now it's also true of D and F. They're also inscribed angles of the same intercepted arc, GE, right here. But by angle-angle, these 2 triangles are similar. What does that mean? That means that corresponding parts of these triangles are proportional, such as the Y right here corresponds with the 4 right here. You can see how they kind of have that corresponding bit. Therefore, the 3 corresponds with the 2 in that sort of same way as well. If you cross multiply, what do you get? 2 times y equals 4 times 3. Boom, 3 times 4. So you get that scenario, that relationship right there, and that's what we're doing. So I'm saving all of the triangle, angle similarity stuff and set up the proportion, and we get to go straight into this, skip the fractions too, straight up multiply. And that's the fun about this, that will kind of actually make this thing quicker. But that's my good heads up as to why that is and where you see it. Now, that's the value of y. The length of segment DE is 7, and the length of segment FG is 2 plus 6, which is 8. I think I'd rather just write the 8 and box it. It looks a little cleaner. It's 8. I don't know if we have to use fractions for these later as well. I was going to say something else. I don't know what it was. Sorry. All right, I'm going to go ahead and move forward. If I think about it, I'll tell you. All right, this next one right here, we're going to same thing multiplying. 6 times 70. Oh, I was just going to say that you might, before I said any of that proof stuff, and you're like, well, I guess it's true. You might argue that you'd think that this would have been bigger. It's a longer chord. Why isn't its product bigger? Because of the way that it's split up. When you multiply 2 numbers that are closer together in value, I'm not going to say they become longer than 2 other numbers that are different in value here, but there is a relationship among that. If you had 2 things the same length, if you had a string, something of length 10, and you cut it in half and did 5 times 5 versus cut it and did 8 times 2, the 5 times 5 will give you yield a bigger, larger value. And that's kind of what's happening here. When this got split up, the ratio-ness was different, and its product gives you a smaller result than that of, well, not smaller, equal. But 3 plus 4 was smaller, and y plus 2 was not. 6 plus 2 was not. Anyway, I'm rambling. Let's keep going. All right, number 6. 10 times x, 10x equals 6 times 7, 42. Divide by 10. X is 42 over 10. I'm going to go ahead and write the decimal here because the addition will be a lot easier to work with. So that's 4.2. It's exact. The length of mn is, of course, 6 plus 7, which is 13. And the length of, excuse me, my nose is always itchy when I do this. The length of LJ is 4.2 plus 10, which is 14.2. So there we go. They do say find the length of each chord, and so that's what I'm doing there. All right, M is the midpoint of segment PQ. That means that this part is broken into two congruent parts. Boom, boom, right there. The diameter of circle O is 13 inches. So this whole thing right here would be 13. And RM is 4 inches right there. Find PM. Well, the 13 is broken up into, I guess, a 4 and a 9. It's more important that I use the 4 and 9 here and what we got to do with those. Now, we don't know either of these lengths, but we know that they're equal to each other. So I'm going to multiply those x's together. This is in general before we talk about the PM. Well, PM and, okay, sorry. X times x gives us x squared equals 4 times 9 gives us 36. Take the square root of both sides. You get x is plus or minus 6. You know that the negative won't really apply to this one here. I got to take it out. We're really looking at just the positive 6 only. So if x is 6, so is the length of PM. PM is 6 inches right there. They're talking about inches here. So 6 inches here. PQ is double that. It's an x plus x scenario. 6 plus 6, 2 times 6, that's 12 inches right there. So that midpoint allowed us to say, I don't know what either is, but I know that they're the same. The diameter, I didn't cut it into 2. I cut it into 4 and its other part, which was 9. And then I was able to work out its product there. All right, number 8. A broken pottery shard found in archaeological dig has a curved edge. I'm just going to follow the image. Find the diameter of the original plate. So we're going to find all of PR here in a bit. Use the fact that diameter PR is perpendicular bisector of chord AB. So if it's a perpendicular bisector here, that means these two parts are congruent to each other. Let's get a lighter color for you. These two are congruent to each other right here. Very similar to what we had before, only this time because there's already an X right here, I probably got to use like a Y and a Y right here. Okay. So, oh, I'm sorry. I wouldn't have to use Y. There's a 5 right there. I was going to say we can't use X because we already know it's X. Okay, so if this is 5, then this is 5. Okay, I was going to say, I don't know if I can solve that anyway. Okay, so we got 5 times 5 equals 3 times X. So this time when we divide, we're going to get X equals 25 thirds. Now, I'd prefer to leave it like that. Otherwise, we'd be rounding our value, and that's actually in inches right here. This is something about an archaeological dig. What did they mention? Okay, so they called PR the diameter. So it is the perpendicular bisector of the chord. They said find the diameter. We got to add 3 and X. So the length of PR is 3 plus 25 thirds, which is 9 thirds plus 25 thirds, which is 34 thirds of an inch. 34 thirds inches, or 11 and 1/3 inches, I think you can also state. Don't do some 0.3 rounding early kind of stuff. That's unless they ask you to round that. I think that's good. Unless I'm missing something else, that's all we're finding there. All right, numbers 10 and 11. Now we're getting to something intersecting outside the circle. Secant lines. So when secant lines intersected inside the circle, we had a certain relationship with lengths, and we're going to have something outside the circle in the same way. Let me tell you what it is first. Let me show you how I know that it works. It has to do with triangle similarity, very similarly to what we did. Well, very similarly to what you saw before. And it works like this. You're going to hear me say this a lot. When you look at this individual secant line with the ABC involved, here's the outside portion and there's an inside portion. But you're not going to hear me say inside very much. You're going to hear me say whole. There's an outside portion. There's a whole portion. Whole portion is 5 plus X, if you can see that. So what I'm going to do is we take the outside times the whole. 5 times 5 plus X. And it equals, in the other segment, the outside times the whole. 6 plus 6 is 12. That's the setup. Why does this work? Well, we have another similar triangle case right here. We have this triangle and this triangle right here. I could make them different colors if you want, but there will be overlap. If you can imagine, here's one of the triangles here, and here's one of the triangles. I tried to do that different color. Here's one of the triangles here. Hopefully you can see the blue and the green still. All right, I guess you can a little bit. They both share an angle right here in A, the reflexive property of congruence right there. That makes that congruent. And then you have this angle E and this angle C right here, which are both inscribed angles for the same intercepted arc. See that intercepted arc for this inscribed angle and this inscribed angle? That makes those congruent. So by angle, these two triangles are similar to each other again. Now when you look at the parts that correspond here, the 5 corresponds with the 5 in blue corresponds with the 6 in green. That's 5 over 6. Now in blue, in blue, the 6 plus 6 corresponds there, and then in green, the 5 plus x corresponds. If you cross multiply, what do you see? 5 times 5 plus x equals 6 times 12. So there's the setup again like we did before. So again, that's outside times whole equals outside times whole. And some of these may introduce quadratics, depending on if you're multiplying multiple x's. In this particular problem, no. So we get to distribute here, and we get 25 plus 5x equals 6 times 12, which is 72. Subtract 25 here, and we get 47. And x is 47 over 5, which is also 9.4. I'm going to say. Is that 47 plus 25? Yes. Okay, so 9.4. Find the length of each secant segment. So we have secant segment AC, which is 5 plus 9.4. That's 14.4. And then the other one was 6. The length of AE is, 12. Is 12. All right. Right here. Outside times whole, 10 times 10 plus y equals outside times whole, 9 times 27. Get out your calculators, folks. 100 plus 10y equals 243. 10y equals 143, y equals 14.3. That's dividing by 10 right there. I hope I did that right. Find the length of each segment. Let's clear this out. Whoa, what did I just do? Wrong tool. Give me 1 second. All right, find the length of each segment here. We get the length of HL. That's 10 plus 14.3, which is 24.3. And then the length of NL is 27. All right. Find the value of x. Okay, here's where it looks like you have some quadratic bits going on. So I have outside times whole. Now, the whole, by the way, is AC. That is x plus 4 plus x minus 2. Right? Both of those together make your whole. So that's going to be 2x plus 2. This is the whole thing that we're going to use when we play outside times whole. Now, this is outside times whole. I'm putting this in front for my OCD purposes. I like to distribute this one on the outside first. Equals outside times whole, 4 times, not 5, but 4 times 9. 4 times 4 plus 5. So this is where you got to deal a little bit here, right? We have to FOIL. FOIL here. We got 2x squared minus 4x plus 2x minus 4 equals 36. So 2x squared minus 2x, and subtract the 36 over, you get minus 40 equals 0. So a little bit of algebra needs to be involved. I'm going to divide everything by 2. We get x squared minus x minus 20 equals 0. So we have to factor here. And I mentioned this in the previous video that factoring would be involved in algebra scenarios. Factor and then solve using zero product property here. So we get x minus 5 times x plus 4 equals 0. If so, that means x equals 5 or x equals negative 4. Now, negative 4 won't really work as an answer here because negative 4 plus 4 is 0. Negative 4 minus 2 is a negative answer. Negative 4 won't work here, but 5 will. Now, they want to find, I think they just say find the value of x, but if you found the length of these segment parts here, this would become a 9, this would become a 3, and then I guess that's how that works out. 4 times 9, 9 and 12, 3 and 12, yeah, that works out. So x equals 5 would work there. See, this would have become 3, this would become 9. 3 times 3 plus 9 is 4 times 4 plus 5. 36 equals 36, so that does work out. That's your value of x. Okay, and the last relationship, see in the previous video I did do lengths with tangent lines only. Tangent and tangent. Those were just equal to each other. What we're doing here could technically apply to it, but we don't really need to when they're just equal. The secant lines we did outside times whole equals outside times whole. This here, I like to say the same thing, only you'll see what's different when it comes to the outside and whole of a tangent line. Find the value here. Here's outside times whole. 6 times 6 plus 8. 6 times 14 equals. Now for the tangent line, if I say outside times whole, here's the thing. The outside length is z. What's the whole length? It's also z. Outside times whole equals outside times whole still applies here. It's just kind of in a different scenario. We don't have to say that. And, you know, in the tangent lines, if they're both outside and whole are the same thing, we shouldn't have to multiply them. That doesn't matter. So 6 times 14 here is 84, and this is z squared here. So you'll see me do those more often if it's just something squared, just straight up. Take the square root of both sides. You get z is the square root of 84. What's the biggest? 14, 6, 12. 4, so 4 and 21. So root 4 root 21 or 2 root 21. Normally I'd put a plus or minus on it, but I think we already know straight up what that, you know, there's no negative version for that answer there. So 2 root 21 is my answer. All right, number 14, outside times whole, 2 times 2 plus x equals outside times whole, that's 5 squared, 5 times itself. Distribute 4 plus 2x equals 25. Subtract 4 divided by 2, you get 2x is 21 and x is 10 and a half. I'm going to put the exacts if they can be exact right there. And they just say find the value of the variable, and that's it for that one. All right, number 15, outside times whole, 8 times 8 plus 12, that's 20, equals outside times whole, y squared. Y squared is 160. And take the square root, you get y equals, it's got to be something larger than 4, right? Yeah, 16. So 4 root 10. Root 16 times root 10 gives you 4 root 10 right there. Like I said, I was going to go fast in the algebra stuff. It's just the setup outside times whole. All these are not circled. How many more? 18, 21, and that's it. All right, 2 more problems. Explain the error. Below is the student's work to find the value of x. Explain the error and find the correct value of x. All right, they do AB times BC. Okay, well, here's the problem already. AB times BC, no, we got to do outside. So BC is correct, outside times, but they need whole, AC. It should be AC here. So that's already the issue. The CD outside times whole, DC is fine. So error is right there. It should be AC. So we should do AC times BC equals DC squared. I know how they write it's kind of weird. It doesn't sound like what I've been saying. But 4 is the BC, that's the outside. The whole is AC, that's 6 plus 4, which is 10. Instead, they did 4 times 6 instead of 4 times 10. X squared, so x squared is 40 instead of 24. All the rest was good for them. They left out the plus or minus because, the correct value should be positive. Take the square root of both sides here. We should get 2 root 10, square root of 40, root 4 times root 10. So error should be AC. Okay, last one, number 21. KL is a tangent segment of circle N. KL is tangent of circle. Oh, but that's not, this isn't a, I was going to put a right angle there. That's not a diameter. It's not intersect the radius. And KM and LM are secants of the circle. Find the value of x. Well, what's interesting, they do say secants, and what's interesting is that's not a tangent right there. There is a value here which we don't actually have information for. When they're saying find the value of x. Let me give I don't think there's a reason for me to know what it is. I'm going to put a y right there to start off with. How do I want to go about this thing here? Trying to see my best approach, that y. Find the value of x. I haven't done these problems to start off with. We're doing our outside times whole scenario things. We can use those, but what I'm trying to decide is, okay, I have an idea of what I want to do. I don't know if it's going to work out in the best way. I think I have to make a system of equations. So let's start with what's out here, here, and here. And I bring that up because that's a secant line right there and a tangent line right here, where we can play our outside times whole equals outside times whole. So, oh, you know what? You can just use that to solve for y. Okay, yeah, that totally works. I don't need a system, but I do need to find out what this y value is. So this, okay, that's only one variable. That works. So if I do outside times whole, that 8 times 8 plus y equals outside times whole, which is 12 squared over there, then I can use that to solve for y. So 64 plus 8y is 144. There's no quadratic, right? Subtract 64, you get 8y is 80. Divide both sides by 8, you get y equals 10. Okay, so that length right there is 10, and I can now use that to find x. So this little guy right here is 10, and I use that now in these two lines here. I have this secant line and this secant line right there. So this time we have outside times whole, 6 times 6 plus x, equals outside times whole 8 times, see this isn't drawn to scale, but this little guy right there is 10. So 8 times 8 plus 10, which is 18. Assuming I got that part right there, I think I did. 36 plus 6x equals, I don't know, 8 times 18. 8 times 2, hold on, I'm going slow. 18 times 2 is 36, 72, 144. I don't know why I did it. I could have done that a lot faster. I don't know why I just did that. 6x equals, what, 108? And divide by 6x is 18. 18. All right, there's my value. No inches, no nothing. All right, guys, that'll do it for this one here. Yeah, you know, I kind of apologized in my previous video before and stated that you're not going to get much brand new exciting from me right here. It's brand new, but yeah, I had to get these ones through. But that'll do it for me. This is Mr. Robinson. If you have any questions, please leave in the comment section down below. I'll probably be cheerier and be able to assist you then. Take care. Have a good one. Thanks.